Okay. Good morning.
Good
Can you hear
morning.
me?
Good morning, sir.
Hi. Okay, you are the first.
Yes, I'm the first one.
Fantastic. So then we have a fellow Jitzer who don't know who he is. Can you identify?
Yes.
Okay.
Can you see my screen?
Yes. Can you put it in full screen? Young? Because now we are just saying the... Okay, good. This is okay. Okay, we will start in a few minutes.
Okay.
Elisabetta mi ha mandato il testo registrato. Mi ha mandato un MP4 dove lei parla. E ho detto, "Ma che me ne faccio?" E mo? Vabbè. Vabbè. Che dire. Ok. Let's try with this. Also, what I need is here. Spell it. Okay. Okay. There is still this fellow Jitzer who I don't know who is, but doesn't matter. Okay.
Oh, I need anything.
No,
Okay.
the speaker probably. Okay, let's try to understand a bit because now with this first session we should have at least 2 colleagues from the general track, which one is the Wrong Young, which is here. Good morning. And Daniel Martins, who is not here, and I have no idea who he is. Then we have Elisabetta Ronchieri, for which I have the material, and then the other, which, to be honest, I don't know, but it doesn't matter. Just start because we are perfectly on time. So, Yang, are you there?
Yes.
Fantastic. So we can hear you, you can hear us, and so the floor is yours, please.
Yes. Now I will start. Okay. Good morning, everyone. I'm very glad to have the opportunity to report some of our recent work at the ICCSA conference. The topic of my report today is numerical algorithm of Barrowman effect in self-generated magnetic field and its application. This work is cooperated with my colleagues Song Peng, Wang Qiang, and Cao Lihua. Now my report is divided into the following 4 parts. Research background, calculation of radiative magnetic field, simulation result is given, and finally is the summary. Now they have a lot of studies on physical model of laser fusion, considering magnetic field effects. Especially this year's after breakthrough of fusion ignition, the U.S. has also carried out a lot of research work on the self-generated magnetic field. The magnetic field has a major impact on ICF. This is the self-generated magnetic field greatly affects the heat conduction of electrons, thus affecting the symmetry of radiation field in Holon. The applied magnetic field has the potential to lower the ignition energy share and increase pressure gain. And here's the development of a numerical simulation program in ICF. ICF is an approach to fusion the realize on the inertia of fusion mass to provide complement. As early as the 1970s, the LASLEX program has included the magnetic field program package and the complete Bransky magnetic simulation is also include the famous hydro programs, and the numerical simulation results also shows that when simulating the typical application programs with magnetic field modeling, the results are closer to the experiment results. Therefore, we also hope to develop such numerical simulation capabilities, including self-generated magnetic field in the ICF programs. So let's think about this dual field model. Assuming the plasma contains electrons, ions, and the completely ions. The following are the mass, moment, and the energy conservation equation for electrons and ions respectively. So we can say the electron and magnetic field are involved in this equation. In order to take the contribution of the magnetic field into account, fluid equations are completely by the Maxwell equations. Here E is the electric field, B is the magnetic field, J is the current density. Now starting from the about moment equation in dual fluid model, the evolution equations of the magnetic field can be derived. Assume first the plasma is local neutral and it is in local thermodynamics equilibrium. Here the mass of the electron is much smaller than the mass of the ion. We ignore the displacement current here. We can drive the general Ohm's law, who links the electron field to other quantities. And this is Faraday's law. So then this general Ohm's law gives the relationship between electric field, the current, and the velocity so that they can be used to enclose the motion of the fluid. In this way, we can obtain such a magnetic field evolution equations. This is the frozen fluid advocation, and this is a whole room, and this is the Barrowman battery term, and this is the resistive diffusion term, and that's why the length term. When the self-generated magnetic magnetic field is considered, and ignoring the relativity effect. The radiation magnetic hydrodynamic system includes mass equations, moment equations, electron energy equations, ion energy equations, radiation transport equations, and magnetic field evolution equations. You can say the whole system is very complex. Uh, the focus of this report is first to introduce how to solve the conflict between the magnetic field effect, the radiation, flood dynamic stress. Also, we focus on the scheme on the Barman uh, Barron battery scheme term, how to discrete. Here, this is the coupling system. The um, The coupling between magnetic field and energy is included in this paper. We can say this term is very complex. It with strong nonlinears and strong coupling characters when considering the magnetic field effect. The electron diffusion coefficient is a tensor coefficient, and our program is based on the Lagrange frame. So our discretization scheme is designed based on arbitrary quadrilateral meshes. Mm. The coupling system relies on mathematics operators of different natures. We therefore have chosen to split it in several subsystems according to the nature of mathematics term. This strategy allows us to develop numerical schemes that are well suited to each operator. It also simplified the validation step since it can be performed separately for each subsystem. And finally, we first introduced the coupling algorithms for the complete system and the related discrete scheme. The whole system contains multimedia and multi-physical process. We very the whole and very complex, so we mainly use the splitting algorithm based on different process, which can greatly simplify the complex system. At the same time, we should physical property of physical operator in different process and try to keep the physical process with numerical discretization. Then we depose the whole coupled system into fluid step and radiation step to calculate the and the mass and the moment equation are first calculated in the fluid step, and the radiation, electron, ion, and magnetic field change are not calculated in the energy. The energy we divide it into radiation energy step and radiation coupling step. This is the fluid step, and the fluid compatibility scheme is used, and the discrete magnetic pressure term here is added into the system. This is the Alice step. We can say when considering the magnetic field, the energy equation has great change. So we focus on the following system and its algorithm. Here, in LHC step, it also used the splitting algorithm to solve radiation hydrodynamics equations. First, the way was electron heat conduction into two parts. The first part is this one. It will couple to the radiation, the I equations, and the first part is the work by the magnetic field to the electron equations. So it will coupled with the magnetic field. At this point, so radiation energy equation we use this is the radiation energy depth. It contains this is the electron ion equations, and this is the magnetic field equations. It is solved with the uh, correct of the electron equations. For this radiation energy equation, we use the matrix splitting method to solve. The first step is to solve the radiation and electron energy equations, and then the second step is to solve the electron and ion temperature equations. In the splitting iteration step, the nonlinear Picard iteration is used to solve the problem, and the magnetic field is calculated explicitly. For the magnetic field coupling step, it should be noted that we need to preserve the energy conservation of the whole system. If we solve the two equations independently, it's hard to keep this property. Therefore, the evolution equation of the magnetic field is solved first, and the total energy equation of electron and magnetic induce is solved in the second step. So we are used so that we are able to maintain the conservation of the energy of the whole system. In the following, we introduce the numerical method of magnetic field evolution, considering the circular magnetic field in two-dimensional string geometry. The magnetic field only has the b theta component. The time is backward Euler in the discrete scheme, and the space is based on the finite volume scheme or any quadratory mesh. First, we discuss the description of the Boltzmann battery term, which is the main physical mechanism of generating the magnetic field. If we look at the parallel target model on the right, when a laser hit a parallel target, it hit up and ablates the material, resulting an outward expand bubble. At this time, the gradient of the electron temperature is close to the horizon, and the gradient of the material density is close to the vertical, and then this cross product creates a vertical magnetic field when the gradient of the initial temperature and the gradient of the electron density are not parallel. A magnetic field is generated, which is called a self-generated magnetic field.
Young, you left 5 minutes, eh?
Yes.
Okay.
The description of this term will use Gauss-Green integral formula to transform the surface integral of palette volume into line integral, which is the scheme 1 we get. In application, it is found that this format has strong syndication on the distort grid. Therefore, we also construct the second scheme. And we can write this scheme in the form of two gradient multiplication and use the least square method to construct the gradient of the grid cell. Here, a grid of line square is used to approximate the gradient. One difficulty that may arise from this term is that he has what is called a short wave disaster. When the shock wave sweeps through, it may artificially produce a mesh that is so squeezed that the electron temperature gradient and the density gradient are not parallel, and then a numerical strong magnetic field will be generated. So we should use a limiter. This is the accuracy of the two schemes shown by the exact solution model. It can be said scheme 1 obtain close to order accuracy on algorithm grid, but on random schemes, the solution will oscillate and the effect accuracy cannot be obtained. Instruct scheme 2 can spread communication to some extent and obtain first order accuracy on random grid. And this is his application to the whole room examples, and we can say it can reduce oscillations. This is other examples. Here is a CH experimental target model. We can say this our code simulate this model. We can say it is in good agreement with the result, but not next result. And this is the CH experiment target model. We can also, the result is agreement with the experiment result. This is a hollow model. Okay, it is simulated by the 6-4 group radiation transport and magnetic field. It is also in good agreement with the other result in the literature. Okay. This is the summary. So focus on the self-generation magnetic field generated by the ICF strong laser, the numerical simulation of the self generation method was carried out, and the mathematical split algorithm, the self-generation magnetic field completing the original hybridization is designed, and the code are developed. The influence of magnetic field on the plasma is primarily studied. Okay, thank you.
Thank you, Yang.
Yes.
Have you finished?
Yes, I finished.
Yes, okay, thank you. Many thanks for the presentation, and many thanks to also to stay within the time. Very appreciated. So this is not, to be honest, my field of activities. But if someone from here want to ask something, the discussion is open.
I just have a question.
I think that you can have to stay more close.
but it's very simple one.
Can you hear Young? Can you hear us?
Can you hear us?
Yes.
Right. Okay.
Just a simple question: is the code you produced available to use it for similar applications? So, for example, available on GitHub or something similar, GitLab.
Young?
Yeah. Okay.
Is the code? Is your code available somewhere? Is public, or can you share it in some way?
It's open source.
Okay. Thank you. Many thanks, Young. So I think that the second now is Daniel. Are you? Okay. Do you have any
Yeah, I have a pen.
pen or whatever? Hmm? No. Good morning, Daniel. Which one you prefer? PDF.
Yes.
PDF. I think that I leave the floor to the technical assistant for that, just to share.
If you put in that website, that link that you gave us, that could read
Yesterday my computer had like an application. This one doesn't have.
So I want. Should I use my computer?
No, it has to be this one.
Because I was hunting with your software that reads the notes, the ones that you send us to us. This one. It's a website. It's not.
Maybe you can try with the PPT, Daniel.
You don't have the notes in the PowerPoint?
No.
Oh.
It is one, the one that you shared on your email presentations.
Okay.
I think it's open. May I?
Yes, sir.
Where is the? You close the.
You want to put it full screen?
No, it's. Where is the website that you put it? Maybe it's better like this. Okay.
Sorry, but I cannot help you.
So I was expecting to use this. But,
Yeah, if it was the app, yesterday it was working on the other rooms because we have like the app and only the presentation.
It's working in my computer. I brought my computer. If you want to, because you send in the email this link, and the people are training with this, and then when we arrive here, it doesn't work. It's not so good.
No, I agree with you.
We
But
can go check if we can like download the app to make
It's
it
not
work.
an app. It's a web browser. If you check on the email.
so can you use your laptop and be connected with Jitsi in order to share?
With the
Yeah, you need to, if you can enter the link.
the two links.
On GT, yeah.
And then use your laptop just to compensate this. In any case, don't worry, because I think that one of the speaker is not here, so we have some time more. We have a buffer. So if we are going to solve this problem, then it is more easy to go on.
Mhm. It's already here. Okay, what do you need also?
Português.
Okay.
Tem que se for aquele site que tem o programa,
Sim.
o outro,
É o
onde
mais.
estava a ver,
Sim.
o detalhado.
Este aqui.
Sim, tem aqui o link, se apresentar,
Também.
aqui no Jitsi, e consegue-nos partilhar.
Ok. Só que o problema é as câmaras, não é? Como é que eu depois. Se calhar a câmara está ligada aqui.
Mas a câmara, essa pode ficar desligada, se falares aqui aparece,
pronto.
tipo, as pessoas
No,
veem
the
na
camera
mesma.
is over there.
Depois
So,
temos aquela câmara.
Pronto, então desligo a câmera, não é?
Sim, e se calhar a
Fico
tradução
permitido.
também ninguém precisa.
okay, then
Sim.
E agora
you have to share that.
partilhar o.
Partilhar o ecrã.
Mas se calhar é melhor desligar também o som desse e fica só o som deste do principal.
Parece-me que vai haver o mesmo problema, porque eu ao partilhar o ecrã, se eu partilhar as notas também.
Pois, esse é o problema. Quando ontem no outro computador tinha uma aplicação que era mais fácil, porque a aplicação punha só o PowerPoint à apresentação.
Eu desconhecia esta aplicação, eu
Pois,
pensei que
também
havia
só
um sistema
aprendemos
qualquer.
que ela disse.
Okay.
Mas
Pronto,
eu posso-
eu vou tentar usar as notas que eu tenho no papel, não vai ser assim uma apresentação muito agradável, mas também se calhar já não ia ser.
Pois, não sei, mas também.
Start.
Okay.
And you have to share, Daniel.
I use this
Okay.
one and
Okay.
and try to. The main issue is that the time doesn't count, and so try
Okay.
to work like this.
It's okay for you?
Yeah.
Perfect.
So it doesn't show the notes. Yeah. Okay, and it's complete.
Okay, Daniel, so the floor is yours.
Okay.
Then you belong to the track, to the general track, right?
Yes.
If I remember well. Okay.
Yes.
So also for you, 20 minutes, and but included the question.
Yeah. Okay. So good morning. My name is Daniel Martins. I'm from University of Coimbra, and today I will present a joint work with Maria João Alves and Cristela Bairrada about the self-space allocation problem with the rectangular arrangement, where we compare three mixed integer linear programming formulations. So, self-space is a key decision problem in retail because the product placement affects the sales and the profits of the companies. There are some aspects that we have to consider in this problem. The main one is the position of the product, both on the row and the column, let's say vertical and horizontal positions, because the placement influences the decision, the attention of the customer. Second are the merchandising rules. Usually, marketing defines that the products should be arranged in a rectangular way, so they are more attractive to the customer and it's easier to replace the stock. When we combine these aspects, the problem becomes computationally very hard. So we'll try to solve that or easier that. Sorry, I forgot to change this one. So the problem we address, as I said, is a shelf space allocation problem. The goal is to decide how products should be placed on the shelves to maximize the expected profit. And the 1 literature model, as we used as it was the original model, or to compare with the ones that we are going to propose.
From remote, can you mute it, please?
It considers rectangular arrangement, as I said, that reflect that merchandising rule. And
رحتي وخلصتي من باب اشتريها اختار هو هذا
لا هيك صديقتي وفوا بعد صديقتي راح تحكي بالانجليزي مو
أنت؟
اجانب ذولا
I will try.
هاي ادمن يا شخص مو طبيعي
لا ماما ملتقى من كل دول العالم شوف
هي؟
يجي دورها تجي حد يقول تلقى
The Firefox, the browser.
لا بس صوت تريد تفتح فيديو تريد تفتح فويس بس انا
No.
ابويا حتحكي انت من انجليزي ما ابويا
لزو الرابط
صرت ابويا تحكين
هي اقدر بس شاشه مكروه بدي عشان
اي ما شفت
مثلا نحضر فد
تحكي
محاضره
Niente,
شغل
mutare.
او جتني حكي
Can you mute, please?
او ماما دخلت
Niente.
Muta tutto, muta tutto, basta
I think they left.
Ah, ok, ce l'ho fatta. So, let's start. Okay, where we are? We are here.
Yeah.
Okay, go.
So as I was saying that the literature model reflects the merchandising rules that I have said and vertical position, but this model has two main limitations. It doesn't include the column attractiveness and becomes difficult to solve for large instances. In this work, we extend the model by including that column attractiveness, let's say the position of product also on the shelf horizontally, and propose new formulations for performance in terms of solution times and best objective values. So here we illustrate a simple case considering only row attractiveness. It's the case of the original model. Literature points that high level, let's consider that this is a shelf on a store. High level is of row 4 and 5. And these points here, these numbers are like attractive indices for that row. We can say that high level rows are the best ones to put the products, and as you go to the edges on the top or on the floor, the attractiveness of the product goes down. Let's imagine that we have 10 products with different numbers and colors to be easier to understand. If we put that 10 products in this way, we this problem will have invalid placement, because let's look, for example, the product 6 is in 2 lines. It's not and also in the columns it's separated, so it's not arranged on the way that it goes to the merchandising rule. So it's an invalid placement. This is in contrast is already a valid placement, because the products are arranged in the rectangular way, and we can see, for instance, the product 2 and product 1 that are forming rectangularity in the rows method and column method, and also are put it on the attractive rows. Maybe they are one of the most profitable products, so that's why they went there. On our product, on our model, we considered also the column attractiveness. That's why the problem becomes more complex, because we attribute also punctuation on the rows, on the columns, so that the central ones in this scenario are the best ones to put the products, and connects with also the rows indices. So this is the best spot to put the product. Then I think it's easier to understand the logic. It's like a heat map. If we consider the more punctuation or the more attractiveness on the columns of the edges, so the positioning of the products will be in this way. We also consider in our work not to sum only the attractiveness of the rows and the columns, but also to do the product of them, so that the attractiveness has more weight to the profit maximization problem, and we compare the results. So I will not enter in mathematical details here. I will skip that, but I will highlight the main data. We have the index of products D, and the index of the rows, also of the columns, and the attractiveness that I refer, it's this AIG that is multiplied by the value of the product in terms of profit, and also considers the position of that product divided by the thickness of it. This model has some key constraints that, as I said, each slot has one product. The products must form rectangles, and also the capacity limit of the shelf cannot be must be respected. Oh, sorry. This part is cut, but I will also not enter in details. To summarize these constraints enforce the consistency of the assignments, the capacity, and the rectangular structure. This is our first proposed model on the work. The key idea is to reduce the number of variables by using rectangle fulfillment constraints, but this leads to a more compact formulation, but at the cost of more constraints, as I said. The idea is, if two slots of the same product define a rectangle, then all the slots inside must also be assigned to that product. Although the SSAP RFA, the name that we are given to this model, realizing big M constraints, we can affect these constraints can affect the computational performance. But if we define that big M as the maximum that the area of the rectangle can occupy, that is rows, the product of rows and columns, this can be overcome. Here we have the example of the idea of the model. If these are two slots that are occupied, the model needs all the slots inside to be also of the same product and the same idea. Searching in a different direction is here. Also the constraints that I will not enter in details. And this is our second model. Sorry. Second model is the SSIP IBRA, because instead of enforcing rectangles indirectly, it explicitly models the rows and columns used by each product, and then the model fulfills the intervals between them. This allows a more direct representation of the rectangle blocks. As a result, it tends to perform better computationally. Also the details, and the software was complete, but also is very mathematical for here, I think. What do we have made? We tested the models on realistic bookstore data. The main result is that the SSIP IBRA performs best on most cases, achieving the fastest optimal solutions in 35 of 44 instances. The SSIP-RFA comes second, and the original model performs best only in a few cases. Here we have the comparison in terms of the number of variables and constraints on the original model and the two that we have proposed. As I said, the SSIP RFA becomes bigger in number of constraints, but reduces the variables. Here we have the comparison of one of the scenarios. In one of the instances, the best time was of the SSIP RFA, but it's cut in the image. But in general, we see that when you use centermost columns as the attractiveness indices, the SSIP IBRA performs best in most of the cases. And also in this case, if we use the edges as being preferred instead of the middle of the columns, and if we assume the same thickness for the products, again the SSIP IBRA outperforms the others, and the second best is the other model proposed by us, that is RFA in one instance. The SSIP RA doesn't perform best in any case.
What is the unit of measure of time?
It's in seconds. Seconds, yes. We have put the time limit of 1,800. So in some situations we have some gap. So it's not the optimal solution can be other, but as I said, the problem is in terms of computer use, it's very difficult to solve. So that was the number that we have defined. So the main contributions, to conclude, the main contributions of our work is that we extend the self-space allocation model to include both row and column attractiveness. With that, we propose two new formulations, the SSIP RFA and the SSIP and IBRA. And the experimental results show that IBRA provides the best overall performance. However, the problem remains computational challenging for larger instances, and for that, the future work will include incorporating behavioral data for estimating the attractive indices, and developing heuristic approach for larger instances. And this is my last slide, so I'll be happy to take questions.
Thank you, Daniel. So, question from you?
The code is running entirely on CPU, right?
The running
On CPU.
Yeah.
You are not GPU accelerated.
No.
It seems like.
But that could be a very good suggestion to use in the future work.
But is single run, or you are also experimented parallel run?
Single run.
Single run?
Yeah.
Okay, single run, single pipeline, etc. Why? Because the code is sequential, basically.
Yes.
Okay. Okay, so maybe, and how much it scale?
How much is scale to?
In the sense that which is the behavior and the environment, the number of data, the amount of data that you put inside the model.
In terms of the products?
Yes.
It's we have 30 products and 3 last instances that we run, and 12 columns to 8 rows. But the problem is also because of defining that merchandising rules, the number of variables and constraints.
So means that if you scale up, you will get some problem with the computation.
Yes. But even though we have already very good results comparing with the original model, but yes, the future work we already started to explore some heuristics to try to achieve a better performance in terms of time, but it's a very complex problem.
Probably without going to high performance hardware like a GPU accelerator, maybe the possibility to explore the high parallel computing maybe is something that is more, let's say, on your cores instead of GPUs, because in the GPU you have to repeat completely the code probably.
Thank you.
But let's see.
Thank you.
You're welcome. Any other?
I have a small question of the first formulation. The question you show us more or less at the beginning to understand this one. Yes. So what are the input data here? So the effectiveness of slot is something you.
Here the only variable on the to be decision is the TDIG, that is the if the problem is assigned or not.
So the others are
already parameters.
Input data.
Yes, input. Yes.
And how you the profit is more or less the profit of the product. So it's a book. It's a, if I understand correctly. While the effectiveness of this slot is something decided a priori, like you showed us before, right?
Yes, we use the index of the literature model, that numbers, but we already started to make some surveys to consumers to try to understand what are the slots with better positions, so we don't use that general numbers and use a more precise number. Also because of the profit, it's not only influences because of the margin of each book, but also because of this let's say leverage that the position can give to the book.
Okay, thank you.
Daniel, thank you. And I have to give the floor to the other participants, to the other speakers. I will get back to you the key in a while. And then the Jitsi here. So the next in the list is Elisabetta, which is not here, but I have a presentation, and if you can help me on that. I have, for example, this. I have this MP4 to be sure. So the next speaker, it cannot be here, but it provides us, let's say, video recording. Okay.
Good morning, everyone.
Okay.
My name is Elisabetta Ronchiari, and I work at an accounting math in Bologna, Italy. Today, I will present our work entitled Artificial Intelligence Assisted Living Systematic Review, a case study in the multi-color electron transform research. This work is a collaboration with Federica Ferraretti, a master student from the Department of Statistical Sciences at the University of Bologna. The research investigates how artificial intelligence can support one
Okay. Now it's better. So let's repeat again. So we have our two colleagues, which are Mingwang. Are you here?
I'm here and I will present.
Hi, Mingwang. Nice to meet you. You can share the screen before we start.
Yes,
Let's try to
yes.
share.
Yes. Wait for a few minutes.
And then we have Rastam as the next one. But before Mingwang. Okay. Perfect,
Yes.
Mingwang.
You,
We can see your presentation, put it in full screen, and obviously you have the other 20 minutes, including question, and the floor is yours, please.
yes. Good morning, everyone. My name is Minh Quang Nguyen from FPT University, Hanoi, in Vietnam. On behalf of my co-authors, I'm happy to present our works on GRI's Online Sustainability Reporting Assessment, a system that uses knowledge graph, enhanced graph architecture, and large language model to answer ESG questions over Vietnamese banking reports. Let me start with why this matter. ESG disclose environmental, social, and government have become central to risk management and investment decision in banking. GRI standards built on impact materialities is a natural reference point for this section, and the pressure is real. Um, at the same time, language model and retrieval augment generation now lets us query these long reports in natural language. So our goal is a simple tools state by hard to achieve evidence grounded and auditable ESG assessment for Vietnamese banks. Problem and challenge. The challenge is that sustainability response are long, semi-structures. They mix narrative table, text, table, and infographics. Standards embeddings only rack struggle here. It can reason across multiple sections. What I need is a retrieval strategy that encodes domain knowledge, the GRI indicator, and preserve provenance. So every answer can be traced back to its the source. Our contribution, which make three contribution. First, GRI aligned extraction pipeline that turn raw reports into performance preserving statement level evidence. Second, an ESG knowledge graph combined with a high risk KG graph framework, graph filtering, semantic vector, and keywords matching working together. And finally, an expert unnoticed benchmarks of 120 ESG questions on which our enhanced configuration attract the highest accuracy, clearly outperforming strong baseline. And next, here is the overall architecture. It has a three modular one process the reports and extract structure evidence. Modular two organize that evidence into an ESG knowledge graph aligned with GRI's standards, and modular trees is a knowledge graph driven graph of retrieval augmented generation that answer the user question. The key idea running through all three is a traceability evidence flow from the documents into graphs and bytes out as a grounded answer. And let me walk through its modules. First, module one, reporting processing. Uh, Module one starts from a corpus of 18 Vietnamese commercial bank with report from 2023 and 2024, average around 60 pages, and we use OCR model to convert the layout heavy PDFs while preserving listing order, heading, and table. We then navigate use the table of contents plus the GRI taxonomies as a sort prior to file ESG risk selection. A Queen 3 model performs schema constraint extraction. It identifies a relevant page, pulls out the statement level evidence, assigns it to an ESG category, and maps it to GRI indicator. And because OCR on the response is noisy, we build in three safeguards: shop TOC, navigation, structure aware extraction, and schema constraint validation. Um, the next is the module 2, module second, ESG knowledge graph. The extracted evidence become a knowledge graph which use Neo4j as a you can see in schema. There are 5 nodes type companies reports, ESG statement, GRI indicator, ESG category connected by relation like has reports, have statement belong to, and relate to GRI. Every node and every ace keeps it provenance. The report and page reference. This gives end-to-end traceability from a high-level entity on the way down to the document-grounded evidence. And module 3 is where the retrieval and generation happen, which you high-risk strategy that combine graphs, filtering with semantics and keyword scoring. Given a question, an LLM first class into ESG ESG then generates a schema constraint cipher query to select the candidate statement from the graph. Those candidates are scored two ways by vector similarity using Queen's embeddings and by keywords matching the critical entity like gear matrix or GRI codes. Finally, the answer generator is a constraint to uh, only the retrieval statement and each one carrier is provenant. So the answer is a uh, verification. So to make the compress, the high risk crazy is an algorithm had a four steps. Step one is classify the question and extract numerics and textual keywords. Step two is generate the cipher query from the schema to build a candidate set with a category level full spike. Step three, score by causing similarities plus keywords. And step four is a high-risk fusion that takes the top three vector results and the two uh, keywords results as the final evidence context. That's the setting. The case vector is three. The case keywords is two balanced cross descriptives coverage with high precision match, and we validate its imperial. The next is a experimental setup for evaluation. We build the graphs over on um, 18 points and run the question on six of them because it's a limited resource, and that's the 10 sustainable report and 2 annual reports. The 120 expected design question break down into uh, 55 environmental, 32 social, and 33 governance. For each question, we retrieve the top three statement and domain expect just each question for the correctness. We compare bylines, uh, BM25 dance and MMR against our knowledge graph and knowledge graph in hand with two answer model Llama 3.1 and Queen trees and it's practical about 4 to 5 minutes uh, to index the response and then around 10 seconds per query on a single RTX 3090. The results and it is clear both language model improve as we move from traditional baseline to knowledge graph driven retrieval. Our better configuration knowledge graph in hand with Queen tree reach 88.1% overall accuracy. Notice that Queen trees benefits the most from the hybrid context, coming from about 77% to 88%. The takeaway is the SAS structural graph constraint combined with hybrid scoring, sharpen even selection is better than embedding similarity alone. So the best model score overall 80 88 percentage, and we have a 5 error-type multi-fact composition, and implicit reasoning is account for 24 percentage.
5 minutes, Mingguang. 5 minutes.
Oh, yes. And to conclusions, our knowledge graph arguments RAG turn layout heavy PDFs into a very GRI aligned problem preserving knowledge graph and hybrid knowledge graph retrieval sustainability with standards baselines 88% vendors with about 55% this improve accuracy, traceability, and consistency for ESG assessment. Going forward, we will extend the benchmark to more sector and as automate pestful metrics. Thank you for listening.
Thank you, Mingguang. Quite a nice presentation, and thanks to be on time to respect the time slot. Anyone from the remote and or the platea want to ask something? Mingguang, I have a question for you. So basically,
yes,
you said in the presentation that you are using, you get the information from only 6 banks and the related stuff. How you see, how you think, and how you try to improve the number of the data, the amount of the data that you have to in some way use it, because so right now the amount of data that you are maybe is not so high for an for a standard, let's say, analysis, let's say that, and you have more results. How you want to improve the number of results that you have, the number of data that you have?
For the data, cross I cross for the website on 18th banks Vietnam, and I construct the data with the expert ESG for evaluation, and the data using for knowledge graph rocks. I using data pipelines, using OSHA model, and TOC navigation to extract the keywords, the statements, the key statement, and using knowledge graph to mapping the key statement with the GRI standards. And for the presentation, I present single and the and for write the research paper. I have 3 candidates, and they are busy today.
Thanks again. Thanks also for the answer, Wang. And we can go to the next and last speaker, which for today, which basically is Rastam. Rastam, are you here with us?
Good afternoon. I'm here.
Good afternoon. So, but maybe Mingguang can stop sharing. Okay, thank you. And then you can share, Rastam, try to share the presentation before to give you the floor.
Okay.
We cannot see. No.
Not see.
Rastam. You should have, let's say, button on the bottom saying start screen sharing, closer to the microphone and to the camera. In the meantime, that Rastam is preparing the screen share, I kindly ask the presenter, Rastam, Mingguang, Yang, to send me their, and Daniel, which is here, to send me their presentation just to put them together in the workshop page. For Daniel, I send my mail in the chat, but maybe I can also write it down to you. And so, Rastam, I cannot see your presentation, to be honest. I cannot. You are not sharing the screen. Now you are. Put it in full screen.
My name is Rustam Safari.
Wait, Rastam. Put it in full screen because it's not in full screen now.
Okay.
So usually can be. Okay, it's Cyrillic your. Full screen.
Oh, it's in the corner.
Here?
On the left.
Not for us, for him.
Yeah, it's this little one.
Okay. Hey, how can tell you? Rastam, go in the left, down in the left, down, go down with the mouse. Go down with the mouse until the bar, which is on the bottom. Then move on the left, and you will again in the left. I miss the mouse. I miss your mouse. Rastam, can you hear me? Rastam, can you hear me? Rastam?
My topic.
Go on, Rastam. Okay.
My topic is mechanisms for identification of micro objects based on the use of characteristics in the image structure. Scientific and methodological foundations, methods, and mechanisms for optimizing the processes of identification, recognition, and classification of micro objects have been developed using tools that utilize dynamic, statistical, geometric morphological and signal characteristics of images. The study examines control systems for industrial and technological complexes, palynology, environmental and ecology monitoring, and medical diagnostics. Methods for optimizing micro object image identification are proposed based on tools for adjusting parameter values for images, point changes, adjusting network structure, variable activation functions, and filtering models for noise, random outliers, and image speakers. Estimates of the mean square error were obtained for various dynamic image identification models combined with the neural network. A software package for optimizing the processes of identification, recognition, and classification of microobjects was implemented and tested.
Sharing like one window.
That
So when you
Rastam,
you can
Rastam, we are only seeing the first slide.
Okay.
Are you in the first
Uh,
slide or are you in the other slide?
in figure 1 shows graphs of the dependency of the probability of the detecting defective points for two signals. A curve of signal 1, B curve of signal 2. Curves with solid line correspond to the traditional algorithm, and dashed and dotted lines correspond to the developed optimization tool. It was determined that the probability of detecting defective image points varies depending on the neural network training step. The graphs which are
Rastam, sorry to interrupt you, but we see the first slide only.
uh-huh.
You should go to the slide that you are presenting because we are just seeing your first slide, the title, full stop. Better. Okay. Okay.
Uh, Figure 2 shows the graphs of the T function, the efficiency of the identification optimization tool with filtering based on the complexity of information processing, plotted as a function of the number of filter stages. Curve 1 corresponds to a filter with an adaptive kernel, and curve 2 corresponds to a double fast discrete Fourier transforms without using a filtering tool. Uh, in figure 3 shows a graphical comparison of the efficiency of an MAF based on the coefficient K, the complexity of image identification, the values of which were obtained depending on the signal frequency of points with uniform division of 3 and 9 channel filtering, as well as the variable adjustment tool. Table 1 shows the average values of quantitative characteristics of image points in a palette of M colors, um, measured over the period of 3 months. The spectral range of signal characteristics of contour image points of microobject was studied using the method that helps determine the boundary shape and cross sectional area of each point. Table 2 shows the spectral portion of the RGB image with background reflections of its parts, left, middle, and right. In figure 4, illustrates the problematic characteristics of the implemented mechanisms for identification, recognition, and classification of microobjects, which are assessed according to the criterion of correct image recognition by on point PI. During testing of the mechanisms, the minimum and maximum boundaries of parameters H, S, and V were determined within which the pixels of the dots were related to acid fast mycobacteria, while the values outside these boundaries are considered to relate to other objects. Table 3 shows the result of testing dynamic models combined with CNN Dovic's wavelength analysis for and a generalized network training algorithm. And conclusion, scientific and methodological foundations, methods, and mechanisms for optimizing the identification, recognition, and classification of microobjects have been developed based on tools that utilize geometric, uh, histological, and morphological characteristics of the image. The developed mechanisms enable processing information about the three-dimensional structure of a microobject, estimating its spatial position and uh, localizing desired objects in the image. Tools for optimizing micro-object identification are proposed, including the selection, filtering, and correction of defective image points based on the extraction of focal features and characteristics of heterogeneous fragments. The mathematical apparatus of neural network training was used at the stage of pre-processing segmentation of microscopic digital images of sputum, recognition of objects, acid-fast mycobacteria, and diagnosis of tuberculosis, and was also introduced into clinical practice, which undoubtedly improves the quality of microbiological diagnosis of tuberculosis. The theoretical results of the study are of practical interest in the design of information processing systems, computer vision of pollen grain images, and images of useful minerals in the composition of rock mass. Thank you for your attention.
Thank you, Rustam. Thank you. Nice study for that you presented. Any question for the remote people or the platea? Actually, I have one, Rustam. Can you hear me? Right. Rustam? Rustam? You're muted? No, it's not muted. Rustam, can you hear me?
Yeah, yes.
Okay, fantastic. So, what is your next step about this research? So, what have you in mind for the next step in order to improve your research? Are you there? Okay, don't worry. Thanks a lot to everything, to every of you, to this let's say presentation for the first session. What I really like is to thank you for your activity and for your work. And please, if you like, send me your presentation, and I will put on the workshop web page as soon as possible. Then for the second part, we will convene at the same room in the same GC meeting at 2. And we start with Serena, and then Berat, Alessandro, and to conclude with Samara, for the second part, for the second session of the workshop. So many thanks to all of you. Many thanks also for to share with us your valuable work. And now we have the plenary session, and then we reconvene at 2 here. Thank you.